Hey guys, Frontwood's Farmer, welcome back to the channel. We got another machining video for you guys. So there's a local company, they don't have a lathe. We've been doing work for them. I actually put a job up in one of my previous videos. Same company, they made these studs. These are B7 studs. I was reading up on them a little bit. I don't know the exact customer for these studs through them. They're more or less like a middleman, but they're used in like boilers and different systems like that. So what they did is they put about 1 inch of thread here, they chamfered it, and on the B7 stud, they went 3 inches up on this side. This is a 5/8 stud. And I'm gonna show you guys a way today that I kind of adapted a piece of carbide tooling to do a radius job. If you don't know how to do that, generally you need one of them fancy radius cutters. Now this trick ain't gonna work for everything, especially if you have a real small lathe. This lathe actually, for this little stud, you think, well, Frontwood's Farmer, it's a South Bend 14.5-inch lathe. It is, but you're going to probably get a lot of chatter with a smaller lathe. It might not even work, but I'm going to kind of explain why it actually works when you don't have much of a relief in the clearance and relief in the tooling. You'd be like, I don't know how that's going to work, but I'll tell you how it's going to work. But a little trick, I'm going to flip around the camera and show you what I did. All right, guys, before I show you all the tricks of the trade here, I got my little rule, and it's got 16th marks, 1/8, what have you. This makes it a little useful. So again, if you're putting on this stud on the 3-inch side here of thread, I'm putting a little radius, which is basically like this, a radius, okay? For those of you that don't know a lot about machining, radii, radius, concave, convex, whatever it is, you get the picture. I'll actually split screen here in a second, and I'll show you what I'm talking about in the drawings. And you need generally a tool that holds in your tool holder that swings. And you can spend anywhere from, for a cheapie, $300 up to $1,500 for a good one. And for this job, it just doesn't pay that. I'm gonna get a couple bucks a bolt, and there's 100 bolts, and it just doesn't add up in the end to spend all that money right off the bat. So what I did is I got the lights on. I need a little more light over here, but hopefully you guys can see this. So what I did is I got a piece of carbide tooling. Let me try to focus on that carbide tooling, get some light on there. And what I did is, it's real hard to see. You really can't see it. It just looks like an edge, but it's not. It goes in and it radiuses. And I put that in a little further than a 16th, okay? Now, when you're grinding the tooling, I'm sure you guys, if you're watching, you already know that's a broken piece of tooling. But here's a good example. Here's brazed carbide here, I think. Let me see. Yeah, a little bit. It's wore. So you could tell when you look at the brazed carbide, it has relief this way. It has relief from this angle, from the other angle. I mean, you only want a little point on whatever you're milling to touch, and that's relief for all that steel to go, okay? If you have a real big lathe, maybe you could get away with it sometimes and not have as much relief, but you're going to probably get chatter either way. Why this works, so if you're finishing with this radius, obviously if that's like going in flat, that's your end radius. It's just not going to work. You would need a tip like I just showed you on a radius tool that swings like this and grind your radius into it. Well, the reason why this works, I couldn't figure it out because I was like, I'm going to try it anyway, is because you're starting with a relief on the bolt side. Think of it as opposite. So normally you want, if you're milling this down, you want this to be a relief, because if your end product, let's first say, well, I could probably find a flat, well, let's just use a blank end. So if you're milling in here, you see what I'm saying? There's no relief there for these shavings to go. It'd have to be like this. You'd have to have a point. Well, your point, instead of being on the lathe tooling this time, it's on a material. And the tooling is the relief side. It's goofy, but it works. Another thing that we did do is I made this sleeve. This is going to probably take as long as this job. And I milled this sleeve, so whenever we go into 3-jaw chuck here, we're not smashing the threads. This aluminum sleeve is a softer metal than the B7. So we'll just chuck that in there, and then I'll just bring this as nice and slow and kind of eye it up, do a little at a time, and then I'll get my rule out, and I'll measure my rule. But I did this. I did cheat. I did this once already, And if you go in completely too, you have no relief, it comes out to a 1/16. But I'm gonna flip the camera around and show you, do a couple, and just kind of want to show you guys this little trick I think you guys are gonna have to excuse a little bit the primitive chuck key. I didn't get around to making one for the new 3-jaw chuck. We put a faceplate, built a faceplate for the 3-jaw. It only came with a 4-jaw. So yeah, excuse that. Again, we're gonna mill out the 3-inch side. And when you're doing this, you're going kind of against the grain here. So you're gonna want less chatter, minimize your chatter as much as you can. So let's run this carriage out of the way. I know you guys can't see real well right now, but I'll just explain it. So what you're gonna wanna do, chuck this up. We're gonna have less deflection the shorter your piece is. I'm gonna figure out my sweet spot first every time. If it's a 3/4 inch out, roughly 1 inch, maybe I get away with a 1/4 or 1/2 inch, but you obviously don't want to crash the lathe, so I'm gonna have to see how far we can put this out, or put this in, I should say. So that looks to be about our sweet spot there. With this spinning around and all, gives us a nice clearance. So you figure 1/2 inch, 5/8 out, that will definitely do it. That's just nice. So you're gonna wanna go around when you use those aluminum sleeves and tighten this thing evenly, because if you don't do that, they'll get loose in there. You could even use a little cheater board, a little piece of pipe, lathe chuck. Like I said, I got about 100 of these to do. So check this, figure out where you want to be. What you're gonna do first. I won't actually do this in one solid motion per se. So what I'll do is I'll get this flat down to my depth, and then once it starts chattering a little up towards the front there, I'm not gonna have any clearance. So I'll start running it then this way with my back, and then I'll go completely no clearance. You're gonna get a lot of chatter, and then I know the bolt's done. Believe it or not, the finish doesn't turn out bad, but if I need to, I will run a little bit of emery cloth over it when I'm finished. So I'm just gonna do this nice and slow. What you want to start doing is you'll see where that's coned in, basically like you're facing it. I know you guys can't see this, but where you can tell all the metal that you shaved, that's how you're going to want to know to judge it to gauge in. You don't need to use a indicator of any kind, really. Should be about good. Kind of let you guys see this now. As you can see, this method works great for these real small jobs like this. I'm going to clean this up with a little emery cloth, and I'm going to run it through the wire wheel, and then I'll show you test fitting it with the nut. There's also a couple ways you can do this. You can try it freehand like this for right now. If it doesn't clean it up to desired finish, you can do it in a 2-step process, and you get something solid, obviously shorter than this. You could use this, a piece of flat stock, and kind of just hold it in there like that. But I don't know. I don't think that's going to be necessary. Let's see. Now that finish is really nice. Even if you want, check it with your rule. Yeah, you have your rate. We're right on our 8th, or yeah, our 16th. I'm sorry, our 16th mark. Over to the old wire wheel. And the wire wheel this. Anytime you chamfer and a nut don't fit, or you put a radius in and something ain't right, clean it up on here. Look how that's a really nice finish. This is a grainy. This is real grainy to begin with. So we got the same finish that they had there from factory, and we got a nice radius, and we didn't spend a fortune on a radius tool. So then we go over and we're going to test fit the nut. All right, the moment of the truth. What separates the great machinist from the good machinist, the farmer machinist like me. Perfect. Always test fit every piece. You don't want, especially if you're not representing the company, because if you're doing work for someone else, that's their name. To me, that's even more important than your own, because you could always take responsibility for what you do, but how do you blame it on someone else? That is a perfect, let me see if we could see that. It's hard to see, but it turned out great. So I'm glad you guys stuck around, because I did a poor example of really explaining this earlier. So let me iterate this one more time. What I meant by your lathe tooling, let's just draw an ordinary piece. This is a carbide tip piece of tooling. When you're going into a piece of material that's square, you're gonna need relief, because you're gonna get pressure all through here. And you're gonna need relief on that piece of tooling, okay? To cut this square piece of steel. Because this piece of steel in your lathe chuck, draw a little chuck here, that piece of steel is square, or at least very close. So what you're gonna wanna do is you're gonna, say if you're going this direction with your lathe tooling, you're gonna want relief here to eliminate this. And then you're gonna wanna, if you were looking at another angle, you're gonna want that same relief on each side. You may even wanna relieve this a little, just a hair, like that. Now, when we're putting in these radiuses that we wanna put in, which are 1/16 from center, okay, I started off, okay, with this piece of carbide tooling like this. So what I meant was, your end result, you're not going to have no relief, okay? Especially if you were going into something flat. However, we're not. We're going on this little corner here, okay, of the rod, of the stud, for lack of better term. So you're not going to get all this stress until you reach every one of those points. And it's funny, because if you do this right, and this equation comes out to 1/16 of a radius, okay, you will literally have no chatter and no relief issues until it reaches this actual radius. So that's what I meant earlier. I'm glad you guys all stuck around. Again, any questions, let us know.